time series analysis with Python and Pandas. We will discuss what is exponential moving average and why to use it. How can you use Pandas to modulate information with EMA? We're going to ask how exponential smoothing works. What is exponential moving average? Simple moving or exponential? How to read and how to use its formula. Plots with Python to understand how and when to use exponential smoothing now. Let's talk about exponential moving average or exponential smoothing average. It is the same. Why? Because when we are talking about moving average, we will calculate different behaviors in certain frame of time for our time series data. It is the first step in something called exponential smoothing. And we could call it simple because it's going to be only using one single factor. In this case, we're going to call it the alpha smoothing factor. It is different than a simple moving average because simple moving average, we don't have any smoothing factor. So when we say simple exponential smoothing, it's completely different than simple moving average, first of all. And what is this smoothing factor used for? Well, it's going to help us to understand when to include or how much to include previous values. And then that's what we're going to say moving average, because on average, we're going to calculate this smoothing factor. Check how we're going to start with an initial value, our first value, and then we're going to calculate the alpha. In this case, we're going to use Python to calculate it, and then we're going to move forward in different periods of time to calculate the approximation that's going to allow us to smooth our plot and our data. Here, you can read that smoothing is going to be our alpha. The value today is going to be the x, and we're going to check they're going to whether increase or reduce previous values of the same exponential moving average here. Let's go. How to give or how much to give to our present value or how much to include from previous values. That's in general what is simple exponential smoothing, controlling this information with the smoothing factor. Check that we're going to use exponential moving average to calculate or to understand the different trends in our data. Exponential moving average reacts quicker in reverse trend, as you can see here, than they compare it with simple moving average. Here, when we have a change in our data, exponential moving average on blue, in dark blue, can react faster than the simple moving average, as you can see here. And also, when we have upward trending, we can check that exponential moving average reacts faster than simple moving average. Then, how to calculate this? Well, there are certain approximations. This is a formula that allows us to calculate in using approximation of the exponential moving average. However, this value here, as you can see, is the number of time periods. Then we have to decide what is going to be that number of periods we're going to use. Compare, and we see P is going to be our X, as mentioned before. Previous EMA is going to be our S. Let's calculate it using certain data frame we already had in the past. And we have it here. This is our data frame. We're going to use these two different columns, and then we're going to plot to compare with the moving average. We are going to compare, for example, before, what is going to be X sub 0? X sub 0 here in sales, this value here, is going to be our S sub 0. And if we decide that we're going to use a period of 3, our alpha approximating is going to be 2 divided by 1 plus 3. Can you see here? Applying this approximation. That's our period, n equals 3. So we're going to use a window of 3. And then that means that our S sub 1 is going to be our previous value. That means this one here, S sub 0, right here, and our present value, 64. Check that we're going to calculate it. That means in this position. And multiply it by the alpha, and that gives us a value of 63. Let's compare with Pandas now. We are going to use the function EWM. And that span I just mentioned is applied here. We say in the F assign, that means we're going to create a new column. The column's name is going to be 3 days in the past. Check. Sales is the column I want to use. And directly using this dot, we know that it's a function from Pandas. EWM span 3 days or periods in the past. And then when we have extract those 3 days in the past, we calculate the mean. That's what we're going to do. And we'll do it now and check now our value here. This one is S sub 0. So it's going to be identical. Check here. But this 63 is a combination of S sub 0 multiplied with 1 minus alpha, 12.5, and then that's previous value, remember, and our current value 64, the one in here, multiplied with the alpha, and with a total value at the end of 63.15. And the same with the next one. You are able to calculate the next values following this approximation used right here. And what it means alpha is equal to 0.5. Well, that means that it's given identical proportion to previous values and present values. That's what it is. Now, let's plot and compare our rolling mean with our exponential moving average. Let's see here, we have 3 different plots in one, and we calculate it here. Now, we can see here that both rolling mean and the EMA are smoothing our data. And we also can see that the trend is still there. There are certain changes over here that EMA is capable of detecting before than the rolling mean as we saw before. That is what it is, exponential moving average, in certain difference with rolling mean in our time series analysis chapters.